here we have 0 of multiplicity 1, 0 of multiplicity 2, 0 of multiplicity 3. Zeros are just x-intercepts, right? So if they say 0, 0, x-intercept, or root. So 0 of multiplicity 1 just means there's 1 there. Remember how yesterday we had that x minus 3 and we had 2 of them, so it was x minus 3 squared, and then at 3 it bounced, it did that tangent, see? That's how you get a multiplicity of 2. So here's multiplicity of 1, there's only 1 here. So go straight through, straight through, straight through. So an example of this equation could be like x plus 3, x minus 1, x minus 5. So my actual x-intercepts are at -3, 1, and 5, correct? And there's only 1 at each, so go straight through. Yeah? Then this one is a 0 of multiplicity 2, so there's 2 of them there, point of tangency happens. So this here we have 1 going through, and then here we have, it hits it and bounces back up because there's 2 there. If it gets wider and wider and wider there, it just means there's more than 2. There could be 4, there could be 6, there could be 8. So here we get an equation that could match this one because we like x minus 3, and then, sorry, x plus 3, and then x minus 4, which would be 4, but how many are here? There are 2, correct? So I have to put squared on it, right? Now, you could have multiplicity 4, 6, 8, 10. Those would all still work. But I can only max out at 5, degree 5 functions, so I'm only going to be able to have 4 at max. So can you do this for me? Can you go to your calculators? The calculator on here tells me it doesn't work anymore, so I have to talk to them about that. In your calculator, can you put this? Y equals x plus 3, x minus 4 squared into your y1? So it's going straight through, bless you, at -3, but it's bouncing tangent at 4, correct? At +4? Okay, what happens? So that would be multiplicity 2, still tangent, correct? In y2, I want you to put this. So x plus 3 stays the same, but instead of x minus 4 squared, I want you to put x minus 4 to the 6. X minus 4 to the 6. What happens? It's fat, as Marlon said. It's wider at that 4, correct? Because what happens is every single time you have another x-intercept, it bounces more. So for this one, if I have 2, it hits it once and it bounces up once, correct? But if I had 6, it's going to hit it, it's going to bounce up, it's going to hit it, it's going to bounce up, it's going to hit it, it's going to bounce up. And what happens down here is it looks wider. Do you see that? It just bounces more. That's all it's happening. But it has to be an even multiplicity in order for it to be tangent. So I would highlight this point of tangency, multiplicity of even multiplicity, because everyone forgets this. Now where the multiplicity 2 comes in is when you state the x-intercept. You'll say this one has an x-intercept at x equals -3, and then x equals 4 multiplicity 2. That's how you describe it when it's an x-intercept, not a factor. When it's a factor, you describe multiplicity 2 by squaring it. Okay, you can clear out y1 and y2. For this one, it makes this point of inflection. So what happens is, it hits it once, and then it hits it twice, trying to send it back down, and then it hits it a third time, and it sends it back up. So it goes like this. This, send it back down, send it back up. So that's how you get 3. If it's 5, it would send it back down, send it back up, send it back down, send it back up. So it just gets wider, right? Just like that 2. So an example of this, because it's at 0, would be y equals x cubed. I could also get a multiplicity, 5, 7, 9, 11, etc. Okay? So in your calculator, can you guys put in, I don't want x cubed, I'm going to get you guys to put in y equals x minus 4 cubed. So this one's technically giving you a function at 1, 2, 3, 4. It's like going like this, correct? Yeah. Okay, make y2 be x minus 4 to the 7. What happens? It just gets wider, right, at that 4. It's bouncing one, yeah? Okay, that's a precursor into what these look like. So, another thing that I want you to realize this as well is, we're going to talk about this way more on the next day, but your graphs for polynomials, if it's y equals x, like ax plus b, let's say, that's just a linear, that's grade 10, right? So it's either going to look like that. You don't need to write these, we're going to talk about this way later. I'm just trying to give you a glimpse of what they all look like, okay? So no writing necessary. Or it could go like this, it could be a negative slope, correct? Or in grade 11, we learned about quadratics, ax squared plus bx plus c, which is a degree 2 function. It can either be concave up or opening up, or concave down, opening down, correct? Then in grade 12, we get cubics, quartics, and quintics, which is degree 3, 4, and 5. So it's just 3 more. So we get y equals ax cubed plus bx squared plus cx plus d. And it looks something like this. Almost like a sideways S. Or it could be downwards and it could look like this, right? Or it could be that one we just saw where it literally just made the S really tighter, okay? X to the 3, do you see how one arrow's up, one arrow's down? X to the 1, one arrow's up, one arrow's down. If you look at x squared, so degree 2, they're both either down or they're both either up. So even functions, both up, both down, odd functions, opposite direction, arrows. We have quartic, which is ax4 plus bx3 plus cx squared plus dx plus e. And that would either make an M or a W. So it just has that extra bounce in it compared to a quadratic, correct? But the arrows are still in the same direction because it's an even degree function. And then degree 5 just has that extra bounce in it. Okay? So it looks like a degree 3, but with an extra one. Okay? All right. Going back to here. So we're going to go over how to solve. So remember factoring in grade 10? Factoring in grade 10 was hard. So we were learning straight from scratch how to factor, right? But we just had to factor and that was it. Then in grade 11, we were told we need to solve quadratics. And the only extra step in grade 11 was taking those factors and setting them equal to 0. And then we just solve for the x, correct? So once you can factor a quadratic, it's really easy to solve it. You just take those factors, set them equal to 0 and solve, correct? So technically we did the hard work yesterday when we were factoring them. So we're going to have to factor these as well. So even though it says solve, solve always means variable equals number. That's what we want. Whenever it says solve, we want to know what the heck x equals. Okay? Well, the only way we can solve these is to factor them. How do we factor them? What's the very first step we're going to have to do? Put that in our calculator. Let's go. If we can factor, we can solve it. First person give me an x-intercept is the one I'm using.
-2.
Now, before I do synthetic division, what do I always have to do? Check if I can what the equation? Rocket count the equation. 4, 3, 2, 1, 0, blast off. Correct? Can I rocket count it? Yes, so then it doesn't need any zero placeholders. So I can put in the coefficients. I get a 1, negative 5, 2, 20, negative 24. Have I done anything different so far, even though it says solve? Nope, this is what we did yesterday, right? Drop the 1. Multiply, negative 2 and 1, negative 2. Add it, negative 7. Multiply, 14. Add it, 16. Multiply, negative 32. Add it, negative 12. Multiply, 24. Add it, 0. And then it's dropped by 1, correct? Because we GCF 1 out. We had an x plus 2 up here. So this is going to be 1x cubed minus 7x squared plus 16x minus 12. How do we factor that? Put it in our calculator. So type that into your y1. Give me the next one. X equals 2. You did a different one, don't panic. You look to the other two factors, right? So this is x minus 2. So we get 1, negative 7, 16, negative 12. Drop the 1. 2 times 1 is 2. Add it, negative 5. Negative 5 and 2 is negative 10. Add it is 6. 2 times 6 is 12. Add it is 0. And this is my remainder. It needs to be 0, correct? If it's not a 0, we've got problems. And then we have 1x squared minus 5x plus 6. When we factor that, we're going to get x minus 2, x minus 3. Now, most people will leave it like that. Remember, you want to check it before you solve it too. How you check it is, if this is a 4, at maximum I'm going to have 4 factors, okay? If they're all linear, I have to have 4 to make the export when I expand it. So I get x plus 2, x minus 2 squared, x minus 3. Now, I could check that by putting it into y1, y2, correct? The original into y1, that into y2. And if I asked you to factor, I would box this and move on. Did I ask you to factor? No. So if I ask you to solve, you're going to go x plus 2, x minus 2 squared, x minus 3 equals 0. Because to solve means you're going to set y equal to 0. So in this case, I'm going to set p of x equals 0. Okay? Well, in grade 11, you would have just had 2. You would have had like x plus 2, x minus 3 equals 0, and you set each equal to 0 and solve, correct? Same thing here. We're going to go x plus 2 equals 0. Move the 2 over, I get x equals negative 2, so that's one solution. Then I get x minus 2 equals 0, x equals 2 is another solution, but if I just box it right now how it is, how in any way do you know there's 2? The way it is currently, you don't know there's 2, right? So in a factor, you know there's 2 because you'll take those factors and you'll square them, correct? In a solve, the only way you know there's 2 is you have to write x equals 2, multiplicity, 2. So when you're solving, you have to write multiplicity 2, or we do not know that there are 2 there. And then we have x minus 3 equals 0, x equals 3. And I have my 3 solutions. Fun fact, those are the x-intercepts of the graph, correct? And you'll see them in your table. When you write second graph, all of these exist there. What is this? Polynomials, right up. I want you to solve it. So first we have to do what to it? Create our calculator so we can factor it. First off, I have to check 3, 2, 1, 0, blast off. And which one did you say? So x equals -1 is the answer, x plus 1 will be the solving, right? X plus 1 will be the factoring. You need to know the difference between the two. Okay, so we have 3, 2, 1, 0. So we're going to get 2, -5, -4, 3. Drop the 2. If you use a different one, does it matter? No, you're just going to get the other two factors when you factor it. So panic already. -1 and 2 is -2. Added is -7. -1 is -7 is 7. Added is 3. -1 and 3 is -3. Added is 0. You get 2x squared minus 7x plus 3. Now do decomposition, right? So I get 2x squared minus 7x plus 3. What times what equals 6? What plus what equals -7? What do we get? -6, -1. So we're going to get 2x squared minus 1x minus 6x plus 3. True? If you have your touching, then it needs to be a plus sign between, so I put that there. Bless you. And I get x bracket 2x minus 1. We go to -3 and I get 2x minus 1. So my factors are 2x minus 1 and x minus 3. And then the logic will say those are the only two factors. What do you have to remember? This one. And you should catch yourself because you should always be checking these. You should always have your original into y1 and your factored form into y2, and they should draw the same graph, and then you should feel confident in yourself, correct? So, 2x minus 1, x minus 3, and x plus 1. If I type that into y2 and this into y1, it should give you the same thing. Because it says solve, I set it equal to 0, and set y equal to 0, and I solve each. 2x minus 1 equals 0. 2x equals 1. Divide by 2, x equals a half. Then I have x minus 3 equals 0. X equals 3. And I don't have to write multiplicity 1 if there's only 1. I have to write it for 2 and 3. And then x plus 1 equals 0. X equals -1. Boom. And those should be my what's on the graph. X-intercepts on the graph. You got it. Okay, we're going to flip over. Try that one. So we have 3, 2, 1, 0. We can rocket count. We're going to have 2, -14, 25, and -4. What can I use to solve x equals what, sorry? 4. Take the 2, drop it. 4 times 2 is 8. -14 and 8 is -6. 4 times -6 is -24. 25 plus -24 is 1. 4 times 1 is 4. Add it and I get 0. You get 2x squared minus 6x plus 1. Nothing factors to that, correct? Do you think on the unit test I'm going to give you one where you have to use quadratic formula? I'm absolutely going to. It's not going to work out perfectly. So, the quadratic formula up here says for the form, and I'm going to write it up here. It says for ax squared plus bx plus c equals 0. That's what it literally says. It says for ax squared plus bx plus c equals 0. So you have to have it in that form. If you have it in that form, you can use the quadratic formula. The quadratic formula is x equals -b plus or minus the square root of b squared minus 4ac, the entire thing over 2a. So, ax squared plus bx plus c is what form we need it in, right? So my a matches 2. My b needs some plus sign, so my b matches -6. And my c matches 1. Do you agree? So a equals 2, B equals negative 6, and C equals 1. Nothing crazy so far, yes? All right, then we have to put it into our quadratic formula. So the catch here is, if you're using the quadratic formula, your x-intercepts are decimals on your screen, right? If you look, you'll have decimals on your screen. That means quadratic formula. So if you found your x-intercepts first off before you even started the question, and you saw that some of them were decimals, you'd be like, well, I know these are quadratic formula. Okay? All right. So we get x equals negative a negative 6. What happens when I get minus a minus? Positive 6. Plus or minus the square root of negative 6 squared minus 4 times 2 times 1, the entire numerator over the denominator of 2 times a, which is 2. Now, I'd like everyone to follow along with the way we do this in our calculators, because some of you guys actually can do this and never get the right answer. So, we go x equals 6 plus or minus. Please put everything under the square root in your calculator just as it looks, but do not use the square root. So you're not putting the square root in, you're going bracket negative 6, bracket squared, minus 4 times 2 times 1. So you're putting everything under this square root in your calculator. So you're going negative 6 squared minus 4 times 2 times 1. You're putting that into your calculator right now. Because we're going to do a reduced radical. Rarely do they actually want this down to a decimal, because you can just pull it off the screen. So technically, your calculator is going to give you 36 minus 8, which is 28. So when you put this in, did you get 28? You should be getting 28, correct? So that gives me 28 under the square root, all over 4. Everyone's following along? Once again, we're going back to grade 10. What's that? It's good? Bad? It's good? It's bad. What is it? You get an error? Did you go, ooh, I bet you I know what you did. Go bracket negative 6. I bet you went bracket subtraction 6. Or, fun fact, you could have made the subtraction be a negative. You have to watch yourselves the way you guys put them in. You have to put them in the way you say it. So we go bracket, we don't go bracket subtraction 6 bracket squared. We go bracket negative 6. So it's the one beside the enter button, right? Bracket negative 6 bracket squared, and then minus 4 bracket 2 bracket. Does it work out? 28? Does everyone now get it to work? All right. Okay, we're going back to grade 10. Just so you know, we never leave grade 10. Grade 10 is the place where we're at. Grade 12, because almost everything we end in grade 12 ends in grade 10 math. Some people think they've escaped it. You see a grade 10 child who's not trying math, be like, try. You need it. Okay? And if they're like, no, I don't want to, say, you do. 30-1, you need it. Okay? So, little caveat of grade 10 over here. You don't have to write this down, I'm just caveating you into grade 10. So remember we had to do reduced radicals and I gave you root 24. I didn't because I didn't teach you in grade 10, but let's pretend I did. Okay, root 24. The only way you can take a number out of a root, a square root, is if it's a perfect square. Right? So like square root of 4 is 2, square root of 9 is 3. So it has to be a perfect square. So can I break 24 up into any perfect squares? Some people tell me 8 and 3. 8 times 3 is 24. Correct. 83, neither of which are perfect squares, so useless. So 4 and 6. So is this a true statement? Is root 24 the same as root 4, 6? Square root of 4 and 6? Take the square root of 4 out, what does it become? 2 root 6. Did you guys know that in grade 10 you could have checked every single one of these? Go root 24 into your calculator. Got a decimal, right? Okay, now put root 4 times 6 in your calculator. What is it? The same answer, because it's the same thing, correct? And then put 2 root 6 in your calculator. Shocking, what is it? same answer, because it's the same thing, just written in a different way. It's just a reduced radical. Do we agree? So you could check every single step in grade 10 if you wanted to. By checking reduced radicals. You okay, Charlie? I know, it's always mind blowing grade 5. So like, what? I was like, well, when you wrote this equals this, that should have been a giveaway that they should be equal, right? And then this equals this. But trust me, I know in grade 10 you didn't find the equal sign anywhere on your page, so I know that's why you didn't know the equal, because you guys didn't use equal signs. Because I reap the benefits of no equal signs when you get to grade 12. You're still not using equal signs. Yeah? All right. So, root 28, let's caveat this one off to the side. Can I make it into any perfect squares? What? 4 and 7. When the 4 comes out, what does it become? 2 root 7. And then I check root 7, can I reduce it anymore? Because sometimes you guys pick too small of a perfect square and you can actually keep going, right? Sometimes it's like root 17. Is there anything I can do with the root 17? No, it just stays root 17. Like sometimes you can't reduce it. There is reduced to state. 17 is a prime number, so for sure can't reduce it. So I'm going to replace this with 2 root 7. Okay guys, can everyone put their pencils down? Because we're past grade 11 now, and we don't have to do the, if I can make it in a triangle, I can cross it off the triangle. That is sheer memorization tactics. That is not understanding, correct? Understanding is what we need in 30-1 because they can give you any type of question in a weird way and you have to be able to do it. All you do is memorize something, that's scary. So, in previous years, people would say, if it's in the front, in the front, in the front, and if it's in this triangle, we can cancel it off. Well, what the heck is the triangle and why are we canceling it off? So you should have said trees. The only way you can cancel something off is if it's in every single thing, correct? So for example, what can I take out of each of these? This triangle, a 2. So, but why? Well, let's try this out. Can I take a 2 out of these top 2 terms? Yeah. And I'm left with 3 plus or minus root 7. True statement? Yeah. What can I make 4 be? 2 times 2? Is that true? One's on the top, one's on the bottom. They cancel off. That's the reason why the triangle still works. Because you're taking the same number out of each of them and canceling them off. You know what I'm saying? If you use the triangle method, you know you can take it out of all 3. Good. But you should understand why you're using it. You're using it because you're taking a GCF out of 2 out of the top and out of the bottom, and they're canceling off. And when they cancel off, these slanted lines are just 1s, right? Every single time you cancel, those are 1s. And 1 times anything goes away. So my answer is 3 plus or minus root 7 over 2. And then everyone boxes it. Comma. Do I have any other solutions? Four. Just 4, because we don't want the factors, right? Now guys, if I asked you to factor this, so that's solving. If I asked you to solve, this is solving. If I asked you to factor, watch this, because everyone does these ones terribly. If I asked you to factor this, your answer would be x minus 4 times 2x squared minus 6x plus 1. That's it. Because can I factor this? No, that would be as good as it gets. So if I actually asked you to factor, that would be the answer. I would have a linear and a quadratic factor, and I'd be done. So if they can't factor, you're like, please let it be a factoring question and not a solving question. Please let it be a factoring question, because then you're done, right? It's really easy if they can't factor, if I'm asking a factor. It's much more complex to ask you to solve. Do D, go. 4, 3, 2, 1, 0. Always check if you can rocket count. I was going to say karate count. Yeah. Yeah, I said rocket. Instead of like, last off, it's how you, I don't know. Pray for me. All right. What are we going to use? X equals what? 3. 1, 6, negative 6, negative 45, negative 54. If you didn't use 3, don't panic. It'll just be the other one in the next one. Okay, so we got the 1 times 3, it at 9, multiply 27, add it is 21, multiply 63, add it is, what's it going to be, 18, and then I hope that's 54. Yeah. 1x cubed plus 9x squared plus 21x plus 18. Boom, boom. What do I get now? X equals 1, 9, 21, 18. Drop the 1, negative 6, add it, 3, negative 18, add it, 3, negative 18, add it, 0. Nothing multiplies to give you that. This is my A, this is my B, this is my C. X equals negative 3 plus or minus the square root of 3 squared minus 4 times 1 times 3 all over 2 times 1. Yeah. And we get x equals negative 3 plus or minus 9 minus 12. What do we get? Oh my goodness. We get a negative underneath. Can we take the square root of a negative number? No. Type in your original graph. Type in your original y equals, please. The x to the 4 one. Then press graph. Yeah, there's 2. There are 2 x-intercepts, correct? Where are they at? Here and here. Can I take the square root of a negative number? No, this is no solution. Because you can't take the square root. We learned this last year in the quadratic formula. Which we're happy this gives us no solution. Because how many solutions are there? On your graph there are 2. And we already have 2. So this one should result in a negative because you can't have any more. There aren't any more. Correct? So our answer is x equals 3, comma negative 6. Done.